All right. I'll just quickly hand it over to Yakub and look forward to you guys watching this first session. Yakub, over to you.
Hello, everyone. I hopefully you can hear me. Hi, my name is Jakub Guy. I'm based in Copenhagen. I'm originally Polish, and I'm cloud solution architect at Danske Bank. And today, hello.
Hey, Yakub, are you good?
Yes, I'm good. Yeah, can I continue?
Yeah, for sure. You should have ability to
Yeah,
go
no
through.
worries. Yes. Yeah. So my name is Jakub Guy. I'm based in Copenhagen. I'm originally Polish, and today I wanted to talk about conversational infrastructure as code. And yeah, I want to talk about the Model Context Protocol and MCP and MCP servers from AWS. And I wanted to demo a quick serverless application built using an agent and MCP servers on AWS, functionless application, so no Lambda functions will be used. And I want to also talk about some security aspects and wrap up with some takeaways and share some useful resources. All right, so infrastructure used to be declared and coded and generated, and nowadays we can also simply discuss using AI agents. And what I mean by that is we have a different ways of approaching infrastructure as code, and it kind of evolved from declarative configuration as code, infrastructure as code. We still use it, of course, in declarative way, the static templates defining resources, but also programmatic way of using frameworks like CDK, Pulumi, which generate those templates or talk directly with the platforms. And also with the rise of AI tools, we can use AI models to help us generate this infrastructure as code. The code which generates the templates or the templates themselves. And with the AI agents nowadays, we can just do it more in conversational way, more agentic way, which I wanted to show you. Right, so model context protocol. That's relatively new protocol, which has been introduced about a year ago by Anthropic, guys behind cloud models, and recently donated by them to Linux Foundation. And it's becoming an open standard for providing extra context to AI agents and LLMs and provide some extra data sources and tools. And you can think of it as a USB-C for AI agents, basically. It follows the client server architecture. So it consists of servers and clients and also hosts. Hosts are just your IDE, which initiate the client server connectivity. And usually servers are local or remote. And it's, as I said, it's just becoming a standard, and a lot of platforms and software vendors are developing their own MCP servers and releasing them so you can utilize them. AWS has released about 64 as of today MPC servers, which focus on different areas of the platform. So like FinOps operations, so networking operations, infrastructure as code, container management, and so on. Today I'll be using AWS CDK, step functions, and API MCP servers. And AWS also recently released an MCP server as a managed remote MCP server. So they manage that, and that way you can talk to the AWS knowledge base and AWS APIs. All right, so I will be using Kiro CLI. Kiro has been rebranded from Q Developer quite recently. And Kiro is just this agentic IDE plus CLI tooling, which you can use sort of like Cloud Code, developed by AWS. And I will be using this just to configure the agents and prompts in my MCP settings, but any similar tool has a very similar configuration, I would say. And you can have local or global agents. So global as in your user's home directory, so you can use it across different projects, or you can have it specifically for your project. As I'm doing this here, so I can share the configuration with you in a GitHub repository. So that way you can customize your agents and put them inside your code repository, so they will be kind of designed to interact only with this code base as your project. In my case, that's a CDK project in TypeScript, basically. All right, a couple of commands, like a slash commands, internal commands, which you can use to interact with your agent, to define the agent, to have multiple agents and swap between them, to change the model, to add or remove and list any sort of MCP servers and tools, and also add extra context and prompts, and save the conversation you have with your agent and load it, resume it. I will also show you some checkpoints, which is really interesting feature in Kira CLI, which allows you to go back in time when you actually want the agent to step back and roll back certain actions it did on your behalf. All right, functionless address book. So I want to demo just how to use this agent and MCP servers by creating a very simple infrastructure of event-driven kind of backend application. I don't know how to call it. It's just 3 services talking to each other: EventBridge, DynamoDB, and step functions. As I mentioned, it's functionless because it doesn't use Lambda functions. It just uses step functions API integration with DynamoDB, direct integration between services. And the whole idea is just to use event bridge to generate custom events, emit custom events, and process them using state machine, which will place it inside DynamoDB table. So NoSQL database. Very simple infrastructure, but it's just it's not about the infrastructure itself. It's just how to generate this code and get it deployed using your agent. I will be providing a couple of resources to my agent as a context, and those are like markdown documents, which I will show in a second, which basically give extra context to my agent. In particular, what is this TypeScript project about? How to use AWS, how to authenticate to AWS using environment variables and some CLI profile, which I defined earlier, and which region to use for deployment. And also list of tasks which I would like this agent to do on my behalf. And I will be asking step-by-step how to, step-by-step, which resources to deploy by the agent. So first it will define it in a code, and then it will deploy it, basically. And AgentsMD also is becoming like a README file for coding agents or any sort of agentic IDEs, and it is also becoming some sort of a standard describing kind of like context of your code base for the agents and how to interact with this code base. All right, I can quickly show you the demo. I have it pre-recorded, and for some reason I cannot share. Here we go.
Hey, Jakub, I just had to stop the presentation. You should be able to share your screen now for the demo.
I am.
Yep.
All right. Okay, so this is a pre-recorded demo, and this is my CDK application. I just need to play it. And this is my agent configuration. So this is my CDK body, which is my agent with some MCP servers defined. As you can see, some variables, environment variables, and also some tools and settings for the tools, limitations of those tools. So the agent only can work inside scope of this project. And also the resources, those are the context documents. I also have some prompts, which are basically like a keywords I can use in an agent to send a prompt quickly for like deployment or building my CDK application. And I also have some extra MCP server configuration, which can be used by multiple agents if I decide to make more agents like CDK body. All right, so I have this markdown. As you can see, it's just very simple markdown context of what it is about. Also, the project gives some context about the project itself, what it is. It's a CDK application, and some CDK toolkit commands for the agent. And the task is a list of tasks, the development tasks I want the agent to do, and also testing tasks. So this is a list of resources with relatively detailed instructions. So how I want them to be configured, including like, event pattern to use, and sort of testing scenarios. So I will ask the model to basically mock some data for me and test the whole solution. All right, so I can start the CDK body. That's my agent, and we'll start loading the MCP servers. And I can do some simple health checks, like if the MCP servers have been loaded, if the contexts have been loaded, and prompts, and so on. So just a quick check if I have everything running as it should be. All right, so I can basically give it a command. So I can talk to my agent, and I'll just tell it to analyze my tasks. And it's smart enough to basically figure out what I want from it and put it into step-by-step instructions. So then I can ask it to work on the first task, and the agent basically use the MCP server of CDK to interact with my CDK application, so to do the modifications of code for me. And I can also review it, what it did exactly. It did some mistakes. It used some old properties. So I will try to build it. I will ask it to build it and figure out itself. And it did. It just found the errors, and it corrected the errors it made itself. So the same model which produced the errors actually is fixing themselves. All right, so I can ask it to rebuild it and see if that works. And basically, I can deploy the resource. So I have my database deployed to cloud, to my AWS account, that I can continue with the next step. That's definition of the state machine, which is based on the Amazon state language. So it defined the resource in my code and also created a state machine. It's an empty state machine, and I'm using AWS Toolkit to actually visualize it in my Visual Studio Code. And I can just continue with the next tasks, basically one by one. Yeah, so the agent asks me if I want to deploy it. I said no, because I want to add extra resources before deploying. So you can also control what the agent is doing by not trusting every single command it's running. Okay, so I'm implementing some event bridge and event rules and related resources, which will trigger our state machine from the event. So the agent added the resources into the code. And I'm just building it again. All right. So I can now see the status of all the tasks which we've done already with the agent. So it will summarize it for me. And yeah, I can see that task 4 is still remaining. So that's enhancement of the state machine itself. So there's no logic in our state machine, and I need to modify it. So I have a task to basically add interaction with DynamoDB from Amazon State Language, which is this core of state step functions workflows. And it will generate me this state machine logic, and it's very simple state machine, which will only add some items into DynamoDB table and fail or success. All right, so I have the resources, and this is my modified state machine. So as you can see, I have the actions which I need. And as I said, I'm using this AWS toolkit, so that allows me to visualize it in my Visual Studio Code. All right, I'm ready to deploy it and build it. So that's what I'm asking the agent to do, and it will start deploying it. I can also see some checkpoints. So until this time, there was a shadow git commands running by the agent, and it gives me some points in time which I can refer to, and I can restore to certain code version, I would say. Okay, so I just deployed it, and I can test it. So I have 2 tests. One of the tests is to generate me some mock data and use step functions execution. So it will use another MCP server to interact with my state machine, and it will generate me some mock data, and it will trigger the state machine and check this status. Right, so you can see it on the AWS console. I have my state machine, and I have some test execution, and I have some dummy data coming in as an input, and I can see the DynamoDB item in my database. So that's fine. That means everything is working, all the permissions are working, and my basic solution is working. Now I can give it another task, which is generate 10 events with 10 more mock fake people to be added into my address book. And this is just to test the event bridge part, which will then trigger the state machine, and it will trigger it 10 times. And I don't have to deal with this, JSON data and produce the, mock data. The agent does that for me. So this is a list of some mock people, mock data, and some fake people, and I can see the executions, and I can also see the records inside my database. So I can see 10 more mock records in my database. All right, that kind of concludes the demo. And yep, I want to talk about some important security aspects of MCP servers, and in general, not only AWS MCP servers, but this is relatively, fresh technology, I would say. So there will be a lot of security updates. So make sure you keep up to date your local MCP servers, and make sure you install them from trusted sources, right? So there's a lot of MCP servers out there. Just make sure that you know what you're installing. Like with any packages, I would say, it's like giving sudo access to your agent. So be very careful about it. Also use least privilege principles. I'm using IAM roles here, which my agent is assuming, and that IAM role doesn't have admin rights. It only has access to specific AWS services and specific shell commands. So you have to make sure that the agent only has access to your project on your file system, and you have to be careful about any network shares, especially in the corporate environments. And you can also set it up to only trust specific tools, like I did that in my my configuration. And the obvious things like don't include any credentials and sensitive data, API keys, and tokens inside your agent configuration, because that agent configuration you can commit to Git. And to be even safer, you can actually sandbox the MCP servers. So most of the MCP servers support Docker, so you can containerize it in a Docker and run it locally, so that blast radius will be slightly smaller if something goes wrong. And yeah, some of the key takeaways I would like you to take from this. So model context protocol, I highly recommend looking into it if you haven't heard about it yet. Think of it as a USB-C for AI models and AI hard applications and agents. MCP servers are there to expose certain data sources and tools, and majority of the platforms like AWS, GCP, Azure, GitHub, Spacelift, they have some MCP servers. And yeah, basically you can vibe code your infrastructure, and it's super fine for prototyping. But if you start talking to your agent and start asking about well-architected principles, and try to make your infrastructure more secure, you will actually produce with its help quite production-grade infrastructure as code, which you can replicate later on different environments. The prompt and context engineering takes a bit of time, so it actually took me longer to create the prompts than if I would actually create this simple CDK application. But then I can expand on this now, because I have some prompts and context developed already. So what's the future of infrastructure as code? We can use this agentic conversational development already. There's also a quite new spec-driven development and a couple of frameworks which already support it. So basically, it's the idea of creating the documentation for your system or your solution, and give agents the power to generate the infrastructure as code and deploy that code. And yeah, so what's coming is probably something like infrastructure as specs. So we define as specs in Markdown, and we ask agents to kind of expand this documentation. Or we could even sometimes skip the infrastructure as code completely. And Spacelift have introduced Spacelift intent, which is this preview thing of talking to the model, talking to the agent, and deploy changes to your infrastructure directly on the target platform, but also saving the state the same way as Terraform, OpenTofu, and Pulumi is doing. Okay, so I have some useful resources. I can share them in the chat in a second. Mostly some links to the documentation, and also to the GitHub repository. So you can see the configuration and all the prompts which I've used, so you can try it out yourself, or just take it as an inspiration for building your own prompts and context for your agent. And yeah, on that bombshell, it's thank you for having me. And if you'd like to connect with me on any social media networks, then yeah, feel free to. I'm active on LinkedIn and AWS Builder Center. Thank you so much.
Great. Thank you, Jakub. We got some good. That was a great session. We definitely got some questions. So if I stop sharing here, sure. I can pull up the Q&A. We can go through this. We've got 9 minutes until the next session. So I can pull these up, read them out, and you'll be able to. We can go through these one by one. So first up, Ravi asks, how disruptive or manageable was the code incrementally as you work through this repo over a period of time?
I would say I was developing the prompts, and yeah, I was not too specific. So basically, the agent was kind of trying to figure out what I want to do, and generating the code which I wasn't really happy with. So I had to repeat the prompts basically to be more specific, to give more specific instructions to the model. But the code quality was relatively good. It was using sometimes some old parameters, as you could see on the demo. So I had to ask it again to kind of fix it. But it was also fixing it itself during deployment because the CDK application wasn't building correctly. So I would say quite manageable, and I was doing that in a quite controlled way, so I can see what the agent is producing for me, and I could fix the code myself or ask it to fix it. Sometimes I was just fixing it and just telling the agent, "Hey, I fixed this. Can you reanalyze what I've done exactly?" And that way, yeah, the throughout the session, the agent was aware of that.
All right, great.
I hope that answers the question, Ravi.
Yeah, if anyone has follow-up questions, you can also just use the session chat. We can continue it there. So question here, if the tasks I give are fairly vague, like not specifying regions, critical properties, to what extent does the agent try to set defaults, or does it ask more and more clarifying questions?
That's a really good question. Yeah, so if you don't specify a region, the default region, so basically the agent is using AWS API calls, and it falls back to the default profile, default region, and so on. So if you don't specify a region, it will just deploy everything in US East 1. And that's as a default of the CLI commands and CDK toolkit as well. So if you don't specify any specific account or region, it will be like more agnostic, but it will just default to the default regions. But it didn't actually ask me anything if I want to deploy to a specific thing. It was just falling back to the defaults. So I had to be quite specific.
Maybe in a somewhat similar vein of context, can an MCP agent get out of context that you fixed? Is it related to how tightly the context is defined, or the context definition?
Probably yes. I mean, it's still a conversation, so I can also tell it to add extra tasks without the context. So I was giving the context, so I don't have to type in the same commands the same prompts every time, and that also kind of build me the step-by-step instruction for the agents. But I was actually quite often modifying this context and telling it to reload the context, because I said I changed point number 4, redo it and reread it and so on. So I was like talking to the agent while developing the context documents. So I would say it's not really tight. You can tell the agent whatever you want, and it will just provide it. I just use the context to talk to the agent in terms of tasks, so I can track what kind of task we have to do and what is the status, and trying to be quite specific in what resources or what configuration I would like it to add into my code. So I would simple answer, it's not fixed to the context. There's just extra context, which I use this context to give instructions to the agent, but I could also type it in. As you could see, I could tell it to deploy or do something else, or go back in 3 steps, or remove some resources. So that's a power of talking to the agent, basically.
Yeah. Okay, great. I've got one here that I can share. For folks in the audience, if you do go over to the Q&A tab on the right, you can actually look through the questions that have been asked and upvote. So that's another way that it's helpful to go prioritize some of these. If you see a question that is really interesting for you, add some upvotes to it, and we'll make sure to hit those ones. So here's one that has a couple upvotes. What's the main advantage or difference of using AWS MCPs over AWS CLI with Cloud Code, which is also conversational?
Yes, I'd say it's quite similar. The MCP servers are designed for specific tasks, I would say. So you have Terraform or CDK or serverless or CloudFormation ones to generate your infrastructure as code. And you also have in terms of MCP servers, you also have those like core MCP servers from AWS, which will load other. It's like a proxy which will load other MCP servers based on the context of your conversation, so you don't have to preload everything. But underneath, if it doesn't have an MCP server, it will use the AWS API MCP server, so it would be the same as calling out AWS CLI commands, because those are the same API calls in behind the stages. So I would say not a big difference. It's just a way of interacting with the AWS platform, and those servers are developed by AWS Labs. So I would say they would have the latest knowledge about different APIs and functionality of the specific services.
All right, great. So good question. All right, thanks to folks going and doing some voting in the Q&A. Definitely helpful to prioritize. So this one is getting a lot of votes. So are there risks of hallucinations over time as agents evolve? I'm asking because it doesn't seem safe to use this for automated CI/CD IaC deployments.
Yes. So in general, models tend to hallucinate a lot of things. And I had interesting cases where the model was hallucinating AWS services which didn't exist, but it would make sense from logical perspective to use a service like this to connect one service to another. So you have to be careful. It's sometimes, I mean, if you're generating the infrastructure as code like CDK, the CDK itself will fail because it will find that those resources don't exist. But if you're using like CloudFormation, which will fail at the time of deployment, then yeah, there will be some hallucinations sometimes, and it's still agent is not doing exactly what you want, and you have to be quite specific. If you're not too specific, it will try to figure out what you want based on previous actions. As you could see on the demo, I deployed something and then it wanted to deploy again. I had to stop it. If I would make a trust to the tool, it will start deploying it itself. Yeah, you could go into kind of destructive loop, I would say. So you have to be quite careful, unless you give it very, very specific instructions. And I think that's the biggest, this prompt and context engineering is the biggest challenge.
All right, similar votes for this one from Rafal. In case you would want to modify the infrastructure created by first task out of many, would you change the task, change the generated code, define a new task?
So as I said, you could in Kiro CLI you could use checkpoints. So basically, it uses a shadow Git. So every modification of the code is saved by the agent in like a shadowed Git commands, and you can go back in time. So I can go back to first task or like before the first task. So basically, I would just remove every modification, but the way I usually work with it is I redefine the context of the task. So I modify the markdown document and I tell it to reload the markdown. And I'm just telling, hey, I gave you the new tasks, or I modified the existing tasks. Can you redo them? And the model basically reloads the file and analyzes the difference and basically performs the changes for me. So you could dynamically ask it to change it. Like you could change your mind and change completely the task or add extra tasks and tell the model to reload the context documents or specification which you created and provide it as a context.
All right, great. I think this one was answered in chat and reply, but what's the extension on VS Code to visualize the resources?
So that's a AWS toolkit. It's so that's a Visual Studio Code extension, and if you use so that's for visualizing the state machines. So AWS has included this workflow studio, which is available on AWS console, into the cool toolkit, so you can visualize it as like an offline editor. And I love it because you can build the state machines in like a low code, no code tooling inside your Visual Studio Code, like a drag and drop, build the logic, and it will generate you the JSON file behind this Amazon State Language. So if you name the file like this, it will automatically load it in this visual editor.
Great. Sloan had a chat here in the session chat, which got some upvotes. So let me pull it over and share this. How do you think about maintaining systems over time that are instantiated this way? Eventually, if we hit maintenance cycles, either internal or from AWS, small config changes, tweets, etc., coming from the declarative world, it's clear how to be explicit about state changing over time. Still a bit fuzzy here.
Yes, so it's generally, declarative versus programmatic approach, I would say. So if you're building platforms and where every change can have a butterfly effect on multiple tenants, then declarative infrastructure as code is definitely much better. For like app-centric development, like a full stack applications, like programmatic is easier, but that can produce a different outcome depending on the programmatic framework which you use, like CDK, for example. But I would say I would use this for like prototyping to generate me code, even like a declarative code. You can still declare it as OpenTOF or Terraform templates, and use it as a base before moving to more productive environment. So this is just to produce the infrastructure as code, not to actually deploy to the target platform. I'm using the MCP servers to interact with my AWS platform, so I can talk to state machines, I can test the state machines, I can mock the data. So I would say prototyping and building like a proof of concept, it's quite useful. Production grade, I'm not sure, not yet, not at this stage. But you can produce the infrastructure as code, which will be production ready, if you know what I mean. So you can prototype, and your outcome can be a good infrastructure as code, and that would follow normal maintenance cycles with CI/CD pipeline and so on. Garrett, you're muted.
Sorry about that. That's the time we have for this one. Wrapping up, I think we're pushing people over to the next session. So Jakub, thank you for this awesome
Thank you so much.
session. And folks in the audience, go connect with Jakub on LinkedIn, head over to the speakers tab to find his profile. We'll see you on the next session. Thanks, Jakub.